Organic materials like flesh and fruit contains various enzymes, proteins, fibers, and most especially the genetic materials like deoxyribonucleic acid and ribonucleic acid. In this demonstration, we are going to focus on the DNA, and we are going to extract it using a method closely resembling the dissolution method. The first step is preparing the organic materials in which the DNA is going to be extracted. In my case, papaya fruit. We need to crush it so that the enzymes and proteins will be broken down structurally. However, for the DNA to be separated, we need to add the extraction solution, which consists of 180 ml of water, 20 ml of dish soap, and 1 teaspoon of salt. Before getting to the DNA, 3 layers must be subdued: the cell wall, cell membrane, and nuclear membrane. By smashing the fruit into a puree, the cell wall is damaged, exposing the cell membrane in the process. The cell wall is made up of mostly cellulose, that's why it's very fragile. The cell membrane is made up of phospholipids which naturally arrange themselves into a lipid bilayer, where the polar heads are on the outside and the nonpolar ends are shielded inside. Phospholipids had one polar head and 2 nonpolar tails. The soap, however, is pretty similar with 1 polar head and 1 nonpolar tail. The difference is minimal, but the difference causes the soap to form micelles instead of the bilayer. Even though they make different structures, they're still similar enough to interact with each other. When added to the puree, the soap will pull the phospholipids from the bilayer and incorporating them into the micelles. This will damage the lipid bilayer and it will become structurally unstable. Further squishing the puree will rupture the membrane, freeing up cell components. The nuclear membrane will undergo the same procedure and the soap will destroy the lipid bilayer, as the cell membrane is also made out of phospholipids. Now, the DNA is free from any entrapment. Although free, we cannot see it yet because DNA is water soluble. Many of the proteins in the DNA have positive charges which interact with the phosphates, and that's what the salt is for. The sodium ions will hopefully displace a lot of these proteins, further freeing up the DNA. The next step is to filter out the pulp and other bigger stuff. After straining it out, we will add the ice-cold isopropanol which I prepared beforehand. Upon mixing, a bunch of white stringy stuff will appear, and that should be your DNA. During the last moments of the video, you can see the DNA separating from the mixture. One thing to note, the DNA is not soluble in isopropanol, but it is soluble in water. The isopropanol is miscible with water, so as more is added, the solubility of DNA decreases. If enough is added, the DNA will fall out of the solution.